Okay, now we are on transfer learning now. Okay, so what is it, transfer learning basically? I think most of you has heard the word transfer learning, and probably some of you have no idea what is basically is transfer learning. Now let's look on this and okay. And okay, transfer learning is basically is about leveraging feature representation from pre-trained model, so you don't have to train a new model from scratch. Or basically, take model is already trained and you put it your new data set into it. You just do you can straight away do the training and the testing. You know, if you don't modify anything, just take ECGs, can just simply go to testing. So it's about leveraging, in this case, feature representation from pre-trained model. The important word is the pre-trained model. Okay, so the important is pre-trained model. Model that has been trained. Okay, when you train the model, you save the model. The save model, when you save it, it means that the model has been trained. So what you're gonna do, take that model that has been trained on certain data set and you just use it. You only change the input, the data sets, and you just go and train. It save time, you know. You just need a few epochs only. You don't need many epoch because the weight and bias is already saved in the pre-trained model. So you don't have to train a new model from scratch. From scratch here mean from zero. They're gonna check the loss, propagation from zero at the end of the day until accuracy is accurate. But in this case, the model is already trained, so you don't have to train from scratch. You probably only train in a few epochs only when you change the class. So you got a pre-trained model. Let's look on the second slide. In a model on a massive data set that can be standard benchmark in a computer vision frontier. The architecture and its weight model can be reused. Okay. So let's back to this one. Okay. Pre-trained model. Say you got Malaysian nasi. Okay. You got 3,000 data set. Okay. And then you got 5 classes. Nasi dagang, nasi. Okay. This is the model you're going to do on your assignment. You submit to me. Then when you submit to me, then means that your model has been trained. So I can simply take your model, instead of nasi lemak, in your case you got nasi lemak when you train it, I take your model, the safe model, I gonna take your model, I got type of nasi goreng. More specific, my work is nasi goreng classification. And then I see your model got 5 models, so I just put here 5 type of nasi goreng. So exactly the same like your model. I only change I also fix to your 5 classes of yours. I put 5 classes, but instead of nasi dagang, I put it nasi goreng Singapore, nasi goreng Australia, and so on. So I got 5 only. And then when I see your train model, basically you train on nasi dagang, but my data set is on nasi goreng only. So it's look like, so I can just use your model and do mine. That's a transfer learning. So I don't have to train from the beginning. Or probably when you train your model in your assignment, you have 3,000 data set, isn't it? On nasi dagang, and you got 5 classes. When come to me, nasi goreng classification, I only got only 200 data set. You know, I only got 200 data set of nasi goreng. And I'm lazy to make the augmentation. And I want to be fast. I need some result very fast. I only got 200. If I train my 200 data set from scratch, I think it's nothing much improvement. It's only 200. It's not sufficient for deep learning. So what I can do is I use your train model because your model is been trained about 3,000. So your model last year has been trained and for 3,000 data set. So I just can take this model and put me here. So I just can use the testing. And let's look what is the outcome. So that's it's better to do that. When you take this model and put in mind, you can again train if you want, just to lose a few things, because from nasi and nasi goreng. Okay, that's basically okay. Leveraging a feature presentation from pre-trained model, so you didn't have to train a new model from scratch. Train model on massive data set. This is what I'm gonna say just now. You got 3,000 data set in your assignment, and you have submit your project, and you have trained your model, and the accuracy is 95%. Then I got only a few 200 photo only on nasi goreng. Okay, so I just can use your train model and put it me. So what I need to do is just make a little bit changing here. So everything the same with your model. The layer, the convolutional, the setup, even the classes also the same. You got 5, I just fine tune here, nasi goreng only 5. If I got put 6, I think I need more training from the scratch, because I put another classes here. Okay, so that's the advantage. When I don't have more data set, so I can use pre-trained model. But when you use the pre-trained model, I think you're gonna pick the pre-trained model that the best. Okay, all right. Then you think it is good, then you can use it. This model can be used directly in a new model for making prediction of new tasks. Okay, if you don't do anything, just copy as it is. No make any modification. You just exactly copy. Remain it like that. You only change the classes, and then your photo, you format it according exactly the same size, the same setup with this one. If this one use 224, so mine will be use 224 as well. So it's when it run, it can be smooth. You have 5 classes, I got 5 classes. And your train model I put here, I haven't changed anything. I just put as it is. So you just can do for the testing. You don't have to do the training. If I changing something here, so I can do that, but it's more faster than from the scratch. Okay. So, all right. So let's see on this. Model is trained from scratch. You got data set. You got this step, basically 1, 2, 3, 4, 5. Okay. You got this typical pipeline. So when you model from scratch, you collect your data set. That's what you do in your assignment 1. From nothing, now you got many and submit. So you reshaping and rescaling your data set like assignment 1. And this is assignment 2, project, and project. Okay. So this is from scratch. You will from scratch. At this stage, you haven't got any model. So you make a new one. You're thinking about how many layer, how many convolutional network you want to do. So that's been from scratch. Then you're gonna train from the beginning, from the first, and so on. Okay. And then you got label, 5, 6 label, and then you design the model. Then at the end of the day, you design the model. So this is the model I designed. I got CNN here, convolutional neural network. I got 1, 2, 3. I got 4 block here, and I got fully connected layer, say 3 layer or whatever here. So you design your model. This is your model from scratch. Before this is nothing, 0. You think something, then you think this is sufficient enough for the convolutional network. Then you training it, set the epoch, first epoch, second, third. If you look at the accuracy, it's not really well. You put more epoch, get more training, and then at the end of the day, if you find the accuracy is good, then you stop. So this is a model from scratch. Then when accuracy is good, then you save it. So this is a model from scratch. Okay, so this one basically are your model. Okay, save the model. Okay, this is the model. Okay, when the accuracy is 99%, say 98% is good, you're gonna save the model. When you save, we're gonna save the setup. The final weight and bias is gonna be saved. That is the important one. Weight and bias, they're gonna be saved in this setup. Okay, and this is what we call pre-trained model. Okay, your model has been saved, then it is the model that has been trained. So that's why we come out the word pre-trained. It's trained before, just simply like that. Pre-trained model, or in other words, model that has been trained with accuracy 97%. That's in a long word lah. Okay. If you put a long word instead pre-training, it is, you can say, the model that has been trained on 4,000 data set with accuracy 97%. You can naming like that. But in short, we said it pre-trained model. When we said pre-trained model, means that this model has been trained for 3,000 data set. For the width consists of this layer with 5 classes, and the accuracy is about 95%. So that's another word we say pre-trained model. When you save, you have when you save the model, you say this is a pre-trained model. Okay, and then say you got rambutan here. Now let develop rambutan classification system. Okay. Last week you bird. Okay. Last week you have developed a bird classification system, and you have trained and you have saved, and this is called pre-trained model. But today we're gonna develop a rambutan classification system, a new thing basically. Okay. Now what you're gonna do is you just take this model. All right. You just take the bird classification model that you trained before last week, and you just simply copy and paste on here. Take this one, just copy and paste, put it there. Because it's been saved, put it there. So this model basically are for bird classification system. And we put it here. Now, because this is a pre-trained model, this is a 93% accuracy according to the bird. Now you just can run this, what happening. And now you need to change this label basically. And this bird is basically type of bird. Now you have to change rambutan. If there is 10 birds, basically to make it easier, you get also 10 birds. Okay, this is 10 birds. Here you also 10 fruit, rambutan, 10 type of rambutan to make easier. Okay, and the input rambutan you have to format according exactly what the input here. If it is used 224, then you use 224 times 224. If this one use 28 by 28, you have to use 28 by 28. So make the life easier because you didn't change any formatting. Just exactly follow the same, just simply change the data sets and the classes. So this is transfer learning. Okay, you transfer the learning from this model to here. Now you save a lot, you have skipped this work for rambutan. You don't have to do this, to do this. You don't have to do the project. What you do, just simply take this and copy and paste and put it there. Okay, so now you got things there. Then you can run it. Let's look how the accuracy of the testing. Okay. All right. That's basically so one thing here. What's wrong with this one example? Anyone? What's wrong with this example? You can do like this, but there is something not really good way. Okay, not really good way because this is trained for birds, and you got the test of rambutan. It might be And this is learn about birds, you know, and the nature are a bit different. That's probably affect a bit. That's probably affect the accuracy here because the context of these are on birds, and if this is ayam, then it's okay, you know, it bit learn. And if it is bird, all birds, and these all are fruit, you can do the transfer learning, but I think the accuracy not really good. Okay, so I think we'll talk about it soon. Okay, so this is one way. I think it's just uh by concept, you know, because this is trained on bird, but now you take it to use for the rambutan. It's not really tepat lah. Okay, but you can do it. This is what we call transfer learning. You can try and error. How is the accuracy of this approach? So that transfer learning. Okay, everyone, you got it? That's the concept of transfer learning. Then the rest, if you understand if you understand this one, then the rest will be the same. Okay. Okay. What if you copy and paste, but you want change here? You want to change here. You want put more layer here. You want to put more classes here. Alright. So if you put more classes, you're gonna retrain back because you have to more classes. You have to retrain, and when you retrain, you don't have probably only change this one only. This one you don't change. That's the way. Okay. We'll see it soon. Okay. So what we call it freeze. Okay, when you copy here from there, you're gonna freeze it all the weight and bias in US took as it is. So that's the word called freeze. When you take it from here, you take it there and you copy here, you freeze all the thing. When you freeze mean it remain as the ori. If you unfreeze, that means that when you unfreeze, that means that we're gonna train it from scratch because they're gonna need the weight and bias are gonna be changed. If you freeze, they're not gonna change. Propagation and losses, they're not gonna change the base and wire when you freeze all. But here you can freeze some of it. You can unfreeze some of it. When you unfreeze, you have to train because we want to find. They're gonna find only weight and bias gonna be changed only the one that you unfreeze only. The rest will be constant remain. Alright, and so freeze. What else? And then okay. So you freeze, then also you change. 2 now. Here you got many, but now you change to 2. Okay, so you can do that. Okay, you can do that. It's got 2 label. Now you got 1, 2, 3, 4, 5, 6, 7, 8. For example, now you change to 2. When you freeze all, can do, or you can freeze only certain block. Can do that. Okay, for the new one. So that basically a transfer learning, the concept. Now, transfer learning has 6 steps. Alright, I think we're gonna stop here for a while, take a break. Okay, see you later.